Okay, today our topic of discussion is about photovoltaic effects and solar cell. Though we have previously discussed this topic, and today also I'll want to give you a brief about this topic, and then we'll see the working. Okay, after that. So the first question is, what is solar cell? Okay, so a solar cell is also known as photovoltaic cell or PV cell. It's defined as an electrical device that converts light's energy into electrical energy. Though the photovoltaic effect uh, can also be called is the effect for which the solar cell can produce the electrical energy with the help of this light energy. Okay, so a solar cell is basically a PN junction diode, and the solar cell are formed of photoelectric cells, defined as devices whose electrical characteristics such as current, voltage, or resistance vary when exposed in light. Okay, if we place a device in the light, and then if the characteristics of the device or the material is changed, that such kind of material or device we can use in this kind of solar cells. Okay, so individual solar cells can be combined from a module commonly known as solar panels. The common single junction silicon solar cell can be produced a maximum open circuit voltage uh, voltage of approximately zero point 0.5 to zero point 0.6 volt. By itself, it is much, but remember, the solar cell are very tiny. Okay, so when combined in a large solar panel, considerable amount of renewable energy can be generated with the help of this solar cell. So a solar cell is basically a junction. Okay, so just give me some time and let me show you one diagram. uh, Sorry, speech story. Okay, after giving the brief, I will show you. Uh, Sorry, here I cannot show it, so I need to stop the whiteboard. Maybe I can show it in Paint. So just hold on. Just hold on. Okay. Okay, now you can. I hope you can see the structure of solar cell. So the solar cell is basically a junction diode. Okay. although its construction is a little bit different from the conventional PN junction diode, a very thin layer of P-type semiconductor is grown on a relatively thicker N-type semiconductor material. Okay, though here in this diagram you can see the opposite thing, so we can take the both configurations. Okay, then we will apply few thinner electrodes on the top of the P-type semiconductor layer. These electrodes do not obstruct the light to reach the thin P-type layer. Just below the P-type layer, there is an PN junction. Okay, as we all are electronics engineers, so we know what is PN junction very clearly, and all these things we have studied previously. If you can remember, in solid state device we have studied these concepts, so it will be very much easier. So this is the basic construction of solar cell. Okay, now when the light reaches on the PN junction, on the diagram you can see the light photons can be easily entered to the junction through a very thin P-type layer. Okay, though the configurations may be altered, as I have told, the light energy which is entered to that entered through that layer and hit the junction can generate a pair of electrons and holes. Okay, that incident light breaks the thermal quantum condition of the junction. The free electrons in the depends on the region will quickly come to the N-type side. Okay, of the junction. So similarly, newly created holes once open to the P-type side cannot further cross the junction because of the same barrier potential of the junction. And as the construction of the electron became higher on the in one side, that is in the N-type side of the junction, and the concentration of hole became more in the another side. So that is the P-type side of the junction, and the PN junction will be behave like a small battery cell. Okay, as a large number of charge, not large number of charge in terms of what energy we require, but if we consider the structure, it's a large amount of charge. Okay. So the voltage setup, and due to this effect, which voltage is generated, this is photovoltage. Okay, if we connect a small load across this junction, we can observe that there will be a tiny amount of current. Okay, so here you can see that if we placed a current meter in this diagram, you can see we have placed a current meter. So okay, and if we take the characteristics, just let me show you the characteristics. Okay. Okay. Now so this is the characteristics. So this is the characteristics of solar cell. and you can see maximum that short circuit current. Okay, and then it can goes down in the open circuit voltage. Okay, and observe all these things you can see in the diagram. And the material to develop this PN junction, this solar cell can be silicon. We can develop this kind of device with the help of silicon, germanium. Okay, all these materials can be used to um, build the solar cells. Okay, but few points we should remember that that must have the band gap of 1 ev to 1.8 electrovolt or ev. Okay, it must have the device which will choose to so before choosing the material we should aware about that what is the band gap of that particular material which we have selected for the for to develop the solar cell. So and the device which we should use, the device have a band gap of 1 electrovolt or 1.8 electrovolt, or you can write it as EV. Okay, EV means must have an high optical absorption. Okay, as we will working with light, so optical absorption should be there. Otherwise, we cannot work if the device cannot observe the absorb the light, then it will be useless to use the device. Okay, so that's why we need to see that also. Then the device must have high electrical conductivity. Then the raw material must have available in the absence of the cost of material. Okay, must be low, because due to this material sometimes the device cost became so high. Okay, and if the device cost became so high, then it will be useless to develop such kind of device, which device cannot be marketized or cannot be utilized in market. Okay, if it is cost is so high. So this point also should be kept in mind, that device cost should be low. And advantages, you can say, for advantages, it's pollution free. Okay, there is no pollution associated with this kind of using this kind of devices. Okay, it can be used for a long time. Okay, it's last long. Okay, this is another advantage. Then the maintenance cost is also low. Once we place the solar cell in a location where we want to produce the electricity from sunlight, and then after once it's installed, then the maintenance is hardly required. Okay, there is no maintenance may be required, but the maintenance is very low cost. Okay, and this advantage may be the same point, like the maintenance is very low cost, but when we first installed it, then it cost much. Okay, it has a high installation cost. And the efficiency, in terms of efficiency, the solar cell has low efficiency. Okay, due to as we cannot get the solar radiation at the same time everywhere, and then there are so many obstructions are there to get the radiations from sunlight. And at the night time we cannot use the electricity. So if we make an average, the overall efficiency goes down for solar cells, because in cloudy weather we cannot use the solar cell. So that's why the hybrid solar concept system is came in picture, which we have discussed yesterday. So in hybrid solar systems, we generally use the solar panel, which helps us to convert the electricity into convert the light into electricity. Okay, and as there are so many disadvantages there, like low efficiency, we cannot convert the light in night time or cloudy weather. So for that particular moment, we can use a battery as a backup, and the energy which we normally used in our daily life, the battery has also limited backup. So we need to also depend on the power grid also. Okay. So if we altogether use this whole systems like power grid, whatever power we get from the line voltage, okay, that voltage, that power can be used. And then there will be some solar panels, okay. So that solar panel can be converted into electricity during the days daytime, and when, and then if it is a cloud, can use the grid line. Okay, so altogether this all systems if we use, so this system is called a hybrid solar system. Okay. And normally solar system is not it can be used individually, but this solar system, if we use individually, we need to depend on some other source also, because of its low efficiency, and it cannot produce the light at the night time. Okay. Then use of solar generation systems. Oh, there is another important point, that in hybrid solar systems, an inverter will be there. Okay, which will play a very crucial role for the whole systems, because uh, the inverter will be connected to the solar system directly, and whatever power is generated through the solar AC power with the help of this inverter, and the battery is also connected to the inverter, so that at the time when the solar cell cannot convert the light into electricity, then battery can be take the charge. And then the line power, that is the power grid line, also should be connected with this inverter, so that when the solar power or battery backup is low, then the power grid systems can be used. Okay. I'll show you the whole structure. Let me draw it. So these are the few things associated with hybrid solar power generation, and I'm showing the whole diagram for hybrid solar systems. So say suppose this is a solar cell or different sections. So one thing you should remember, that in solar, if we use 30 plates of solar panel, it can generate 15 volt. 15 volt. Okay, so to generate 15 volt, we need to use we need to use 30 solar panel. So if a solar panel is structured like this, and there are 1 2 3 1 2 3 4, so 12 boxes are there. So if we use this solar panel, it can generate 6 volt. So you can see with how what will be the efficiency for this kind of solar cells. So the efficiency is low. This is a drawback of solar cells. So there is the inverter. This is solar. This is hybrid inverter. HI. Okay, hybrid inverter. This is nothing but the inverter. Then there will be battery. then there will be battery, so more or less it looks like battery. Okay, and then we have the power line. Power line means whatever power we got from the line voltage, whatever power we normally use. Okay, so this is a tower. That's what I was trying to show. And then we have our home appliance. That means whatever voltage or power we use. This is home. So this is battery. This is grid, and this is application. Home application. Or you can say it as load. That means it can be a fan, it can be a mobile charger, it can be a laptop, it can be any light or anything whatever we use in our home. Okay, so this is it. And then the connections will be normally we will take the power. Normally we will take the power from the solar panel. Normally we will take the power from solar panel. Okay, we will not provide the power to solar panel. So solar panel will produce the DC voltage and it will transmit to the hybrid inverter system, and this inverter will convert the DC to AC. Okay, and there are some controller also, and I will tell you what is the purpose of controller. And then this power will be sent to uh, the home appliances. Okay, so normally if we use solar cell individually, then this kind of connections will be there, where this solar panel will convert the solar radiation, and it will convert the solar energy to electrical energy, and it will transmit to load through the hybrid inverter. Okay, but we have studied that there are so many disadvantages are there associated with solar cell. So we cannot rely totally on the solar cell. We need to take a backup systems. Okay, so for this backup systems we normally use this battery. So this battery can be provide the power to the inverter, and when the battery is discharged, it need to be charged. So it will take the power from the inverter. So it is a two-way. Either it will take power from the inverter and it will charge the battery, or at the time when there is no solar power or there is a failure in power grid, then it can provide the power to the load. And then so it is a two-way. And we have also power grid, so we'll directly take the power from grid power. So this is the whole diagram of hybrid solar systems. Okay, so there will be solar panel, and as this is a 12 division of sections are there, so this solar panel can convert can be used to generate 6 volt power, and if we require 240 volt, we should require double of solar cells. Okay, then we have the battery, which can take power for charge the battery, and at the time of requirement it can provide the power to home load. And then we have grid power, which we normally use in our daily life. So what happened, sometime we face power failure in grid, so at that time we can use the battery as a backup. And then we have the solar cells also. So when the power when the solar cell is working properly, or there is a sunny day, we can totally depend on for that particular day and particular time, we can totally depend on solar cell also. So it will helps us to reduce the cost of electricity consumption, and at the same time it can charge the battery, so that when the there's a backup power system, so that we can avoid use the grid power. And as we can avoid the use of grid power, our electricity bill will be minimized. Okay, so this kind of thing associated with solar cells. And I used to discuss about the photovoltaics effect also, but I was thinking that I should discuss it on the next day. So I'll stop the recording now and I'll take some questions answered.